Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, in this video, I am going to discuss about question bank of Model 5. So, what is the Model 5 in our differential equations is vector integration. So, what are the contents we are having in vector integration and what are the formulas and what are the theorems we are having? Just I will recall here. So we are having line integral here, line integral, surface integral and volume integral, and three more important theorems are there in vector integration. First of all, what is the formula for the line integration and what are the formula and what are the theorem statement? Just I want to recall you. After then I will move to question bank questions. So here line integral is, the formula is integral over C f of r dr, and if they are asking to calculate the work done by a force, here W equal to integral A to B f dot dr, and this is about the line integral. And if they are given surface integral of the field is, you can see here, double integral. Here surface integral means we are going to get the double integral. So double integral over S f ds equal to double integral over S f dot n ds. So here we are having a different planes, that is we can get xy plane, yz plane and zx plane. So based on that we are having the formulas here, we can observe. Consider a continuous function f of r and a surface S if n is a unit normal. So this is the unit outward normal to the surface at any point. So then we can say that integral over S f dot n ds is the normal surface integral of f of r over S. This is the normal surface integral of f of r over S. So here if you are taking the xy plane, the projection of surface on xy plane, then ds equal to dx dy by n dot k. So if you're taking projection of the surface on yz plane, here ds equal to dy dz by n dot I. So here we are going to use the three-dimensional surface. So if it is three-dimensional, we can't calculate that three-dimensional value properly. So we are taking the projection here. Based on that, we are selecting the planes. So here projection of the surface of the xz plane is ds equal to dz dx by n dot j. So here we are using the formula for the unit normal, that is n equal to del pi by mod del pi. And here we are going to use some of the formulas for the vector differentiation, that is divergence f, that is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. This is the divergence f. And some of the equations we are going to use curl f. Curl f equal to rate of I, j, k and quotients of one function and quotient of other function. So quotient of x, j and k values for the first function and quotients of x, j and k for the second function. So now we are going to use a calculate the det value to calculate curl f value. And we are having a volume integral. What is the volume integral is, you can see here, volume integral, an integral which is evaluated over a volume bounded by a surface is called a volume integral. So if you are taking f is f1i plus f2j plus f3k in a vector field. So then volume integral is given by triple integral over v f bar dv. Triple integral over v f bar dv. So here we are having these three integrals. One is line integral, second one is surface integral, and third one is volume integral. Third one is volume integral. These three integrals we are having in the vector integration, and three more important theorems are there. The important theorems are Green's theorem, Stokes theorem and Gauss divergence theorem. Third one is Gauss divergence theorem. These three theorems are important theorems in the vector integration. So here, what is the statement of Green's theorem? Otherwise, what is the different formula for the Green's theorem? Here we can see R with the simply connected region with a piecewise smooth boundary C oriented counterclockwise. If capital M and capital N have continuous partial derivatives in an open region containing R, then integral over C m dx plus n dy is equal to integral over C m dx plus n dy is equal to double integral R dou n by dou x minus dou m by dou y into dy. So dA, nothing but this is the area. We can write this one as a dx dy. So you have to remember these formulas or the statement of the Green's theorem. Then only we can calculate the problems by using the Green's theorem. And we are having second one is Stokes theorem. So here we can observe in the Green's theorem single line integral to double integral. So here we can change or we can calculate the given problem by using the line integral, otherwise by using the double integral or surface integral also. So we can see the second theorem, that is Stokes theorem. So Stokes theorem statement, by using this we can write the formula double integral over single integral over C f dot dr. So this is the line integral is equal to double integral over S curly f dot n ds. This is the curly f dot n ds. So here we can calculate the given problem by using the line integral and surface integral. That means we can convert or we can transform line integral to surface integral. That means single integral to double integral. So we can use the Stokes theorem to convert or to transform the line integral to surface integral. And here Gauss divergence theorem. Next theorem is Gauss divergence theorem, an important theorem. Here Gauss divergence theorem is double integral over S f bar dot n ds is equal to double integral over v del dot f dv, otherwise f dv. So here we can observe in the statement. So double integral. So that means we can transform the given function or problem from the surface integral to volume integral. So these three theorems are very important. Why? Because these are the important means we can transform the line integral to surface integral and we can transform surface integral to volume integral, because some of the problems we can solve very easily by using the line integral. Some of the problems we can solve by using the surface integral, and we can solve some of the problems by using the volume integral. At that time, if you are having only surface, only line integral, only surface integral, only volume integral formulas, we can calculate those problems by using those formulas only. If you are using these three theorems, we can transform line to surface, surface to volume. So like this, we can use these theorems to simplify the equations or to solve the problems very easily. So these are the three theorems, and these are the line integral, surface integral, volume integral, the contents we are having in the vector integration. So we are moving to question bank questions here. We can observe, already we know this. In the question bank, we are having the three parts. In the part A, we are having problem solving and critical thinking questions. So in the second part, that means in the part B, we are having the long answer type questions. In the part C, we are having the short answer type questions. So first we are going to discuss about the part A, that is problem solving and critical thinking questions. See the first question. Verify Gauss divergence theorem for f equal to x square I plus y square j plus z square k. Taken over the cube. Here they are taking the cube. That cube here we can draw here. So cube. This is the cube. So here we are having x equal to 0 to this is the x-axis, y-axis and z-axis. So here we can take x is 0 to a and x equal to 0 and x equal to a, y is 0 to y equal to 0 and y equal to b, and z equal to 0 or z equal to c. So we have to read or see the question properly. Here they are asking verify the Gauss divergence theorem. So for this function, so first of all, what is the statement of the Gauss divergence theorem? So already just now I given information, double integral over f dot n ds is equal to del dot f dv. What is the statement? Double integral over f dot n f bar dot n ds is equal to triple integral over v del dot f dv. So this is the statement of the Gauss divergence theorem. So here they are asking to verify the Gauss divergence theorem. That means we have to calculate LHS part and RHS part. After then we have to show LHS is equal to RHS. So why we are telling this one means they are asking to verify the Gauss divergence theorem. So if they are asking like a second question, you can observe the second question here. If they are asking using Gauss divergence theorem means you can calculate LHS part or RHS part. So anyone we can calculate to get the solution here. So if they are asking verify means we should calculate LHS part and RHS part both. Then we have to show that LHS is equal to RHS. So here for the LHS part we are having the surface integral. So according to the formula, we have to take here first of all x equal to 0 and x equal to a, and y equal to 0 and y equal to b, and z equal to 0 and z equal to c. We are having the limits for the x, y, z. So first if you are calculating RHS part, RHS equal to triple integral. So x limits are 0 to a, y limits are 0 to b, z limits are 0 to c. So here we should calculate del dot f, that is into dv. So what is the del dot f here? Del is I dou by dou x plus j dou by dou y plus k dou by dou z. Dot, what is the f value? X square I, y square j plus z square k. Now we are doing the dot product. Already we know I dot I equal to 1, j dot j equal to 1, k dot k equal to 1. According to that, dou by dou x of x square plus dou by dou y of y square plus dou by dou z of z square. So here this is 2x plus 2y plus 2z. So this is the value of del dot f. So finally this is integral 0 to a, integral 0 to b, integral 0 to c. This value is 2x plus 2y plus 2z into dv. dv is nothing but dx dy dz. So 2 is the constant, taking out integral 0 to a, 0 to b and 0 to c, x plus y plus z into dx dy dz. So this is the function we are going to integrate by using the dx dy dz. Already we know the limits also. This is about the RHS part. In the same way we have to calculate the LHS part. See here, double integral f bar dot n bar into ds. So here, which surface we are taking? So in the cube we are having 6 faces. So this is the first one, and this is the second one, and this is the third one, and upper 4, 5 and 6. So for the sixth face we have to calculate S1 plus double integral over S2 f bar dot n bar ds plus S3 double integral over S3 f bar dot n bar ds and plus double integral over S4 f bar dot n bar ds plus double integral over S5 f bar dot n bar ds and double integral over S6 f bar dot n bar ds. For all surface we have to calculate the f bar dot n bar ds value. After then you can add these all values to get the total surface, that is f bar dot n ds. That is, this value is equal to RHS. In this way we can calculate the We can verify the Gauss divergence theorem for the function f equal to x square I plus y square j plus z square k. See the second question. Using Gauss divergence theorem, evaluate double integral f ds for the f bar equal to yi plus xj plus z square k for the cylinder. They give one cylinder part here. So, and here, circle is there, that is x square plus y square equal to a square, and z also is there, that is z equal to 0 and z equal to b. That means z limits are z equal to 0 to z equal to b, and from this circle equation we can get the one more limit. So if you want to take the y limit, so y square equal to a square minus x square, so y equal to plus or minus square root a square minus x square. So if they given here, this is a total reason, that means we have to take y limit as a plus minus square root a square minus x square to y equal to minus square root a square minus x square. And when we are taking y as a variable, then x limits are minus a to plus a. So z limits we know, x limits and y limits we know. We can calculate a triple integral over v del dot f dv. Otherwise, we can calculate the double integral over s f bar dot n ds. Both the values, which is you are feeling easy, you can calculate those values. Because here they are asking using Gauss divergence theorem. That means you can calculate LHS part or RHS part. Any one value you can calculate. And you have to remember, if they're asking verify, means we have to calculate both the values and we have to equate. We have to prove that LHS equal to RHS. See the third question. So third one is they are asking here using Green's theorem. So what is the Green's theorem statement? You have to remember. In the plane, evaluate double integral over c 2xy minus y square into dx plus x square plus y square into dy. Here, where c is the region bounded by y equal to x square and y square equal to x. So y equal to x square means we can observe like this here, and here y square equal to x means this is the graph like this. So here this is the 0 comma 0, and here this is the point 1 comma 1. So like this you have to take the graph, because based on this only you can calculate the line integral. Why we need the line integral? First of all, you have to write the statement of the Green's theorem. What is that? Integral m dx plus n dy is equal to double integral dou n by dou x minus dou m by dou y into dx dy. So now, by using this, we are going to compare this one m dx plus n dy. So write the m value. So m value is 2xy minus x square, and n value is x square plus y square. So now we are going to calculate dou n by dou x and dou m by dou y. So dou m by dou y. So with respect to y, we are doing here 2x, y is 1. So x square is 0. So finally this value is 2x. And now we are calculating dou n by dou x. This is 2x plus 0. So finally this is 2x. Now we are going to replace here. So this is m dx plus n dy integral is equal to double integral dou n by dou x minus dou m by dou y into dx dy. So you should know about the x limits and y limits. So first we will calculate this one, then we can discuss about the limits now. So based on the graph, so dou n by dou x value is 2x minus dou m by dou y value is 2x. So here this is becoming 0. That means finally this value is 0. So if you're having the value here, you should take the x limits and y limits. Then we can integrate this function according to these limits. Then you can get the value. So because here they are asking only using Green's theorem. So we have to apply the Green's theorem here to calculate the single integral over 2xy minus x square into dx plus x square plus y square into dy value. In the same way, we can observe here, fourth problem, apply Green's theorem to evaluate. So here, what is the m value? So m value is, so here m value is xy plus y square and n value is x square. So here they given y equal to root x and y equal to x square. In the same way, like that, for the graph, we are going to get same graph to get the limits of x and y. So here dou m by dou y. So dou m by dou y is x into y value is 1 plus y square derivative is 2y. And here dou n by dou x. So here x square derivative is 2x. So now double integral dou n by dou x is 2x minus dou n by dou m by dou y value is x plus 2y. That means minus x minus 2y into dx dy. So now 2x minus x is x. So x minus 2y into dx dy. Now by using this graph, we can calculate the limits of x and y. Then we can integrate this function by using those limits. So the next problem. So see here, verify Green's theorem in the plane for integral over c 3x square minus 8y square into dx plus 4y minus 6xy into dy. So here we can compare with m dx plus m dy. So m value is 3x square minus 8y square, n value is 4y minus 6xy. So now dou m by dou y we are going to calculate here with respect to y we are doing. So first term is 0 minus 16 into y. This is 2y, right? So this is the minus 16y. And we are writing here dou n by dou x. So here 4y. So with respect to x we are doing. So this term is 0 minus 6y into x value is 1. So finally this is 6y. Now integral m dx plus n dy is equal to integral over dou n by dou x is minus 6y minus dou m by dou y is minus 6 plus 16y into dx dy. So now this becomes integral 10y dx dy. So here based on the limits we are going to get the value. So we can see here x equal to 0 and y equal to 0. So on x-axis, this is x-axis and this is y-axis. So on x-axis y value is 0. On y-axis x value is 0. So now here x plus y equal to 1. We can observe this line as a x plus y equal to 1. So now from these values we are going to get the x limits from x equal to 0 to some value and y equal to 0 to y equal to. So I can write here x equal to 0 to and x equal to, I can take 1 minus y. Otherwise if you want to take the variable y as y equal to 0 to y equal to minus 1. So otherwise here 1 minus x. Then we can take x as a constant or y as a constant. So based on that we can calculate the double integral over dou n by dou x minus dou n by dou y into dx dy value. So the sixth question here, verify Stokes theorem. So Stokes theorem. So what is the statement of the Stokes theorem? You can see here. So integral f dr is equal to double integral f bar dot n bar ds. This is the statement of the Stokes theorem. So what is the f function they given here? Y minus z plus 2 into I plus yz plus 4 into j minus xz into k. So here x they given x equal to y equal to z equal to 0. So x equal to 0, y equal to 0 and z equal to 0, and they given the values x equal to 2, y equal to 2 and z equal to 2 and above the xy plane. We are having the limits from x equal to 0 to 2, y equal to 0 to 2 and z equal to 0 to 2. We can use these limits to calculate the integral f bar dot NDA. So here we have to do along the curve, otherwise we can take the double integral f bar dot NDS. So but here they are asking verify. Verify means we have to calculate the LHS part and RHS part. That means you have to calculate both values. You have to show this is equal to RHS, LHS equal to RHS. So based on that only our problem will be complete. So verify means we should do the both values. See here, verify the next problem. Verify the Gauss divergence theorem. So Gauss divergence theorem is integral f1 to dr is equal to. So see the Gauss divergence theorem, double integral f bar dot n ds is equal to triple integral del dot f into dv, triple integral del dot f into dv. So what is the f bar value they given here? F bar is x cube minus yz into I minus 2xy into j plus 2z into k over the cube they given. So like a first problem we discussed about the cube. So we have to construct the cube here. We are having 6 bases. Based on that, we have to calculate the surface integral value. What is the LHS in our statement of the Gauss divergence theorem. Otherwise, we can take the dv value, otherwise del dot f value, and we can use the x, y, z limits because already they given x equal to y equal to z equal to 0, and that means here we can take the x value is 0 to x equal to a, and y value is 0 to y equal to a, and z value is 0 to z equal to a. So these three values you can take, and based on these limits you can calculate the dvf value, double integral dvf value, and we can use the surfaces here to calculate the f bar dot n ds. So the eighth one, verify Green's theorem in the plane. So by using this function, and here we can observe the figure. So here we can observe the figure like this. So here we are going to calculate along the line integral. That means we can take this one, this and this. So here this is a 0 comma 0. This is y equal to x square, and here y equal to root x. Now we have to calculate this is the c1 and this is the c2. That means integral c1 f dr we have to calculate plus integral c2 f bar dr we have to calculate. This is equal to integral over c f dot dr, integral over c f dot dr. So this is the value of first LHS part. After then we can calculate double integral over 2n by 2x minus 2m by 2y into dx dy value based on the limits of x and y. See this question, f equal to x square, right? F equal to x square plus y square into I minus 2xy into j. So here what they are asking, evaluate integral f bar dot dr bar. That means here we need to calculate the line integral. So based on the values, so here they given xy plane and y equal to 0 and y equal to b and x equal to 0 and x equal to e. So we are having the limits for the x equal to 0 and x. So here we have to observe they given the rectangle. Rectangle means we have to take here that's rectangle, and one more important point, they given x values and y values are starting from 0. That means this is in the xy axis. So this is xy plane. So xy, this is the x axis and this is the y. And here we can observe on x axis y value is 0. On y axis x value is 0. Now x equal to 0. Here x value is a. Here y equal to 0, y value is b. So based on this, we can take the limits. If you are calculating this first value, so we have to take here y equal to 0 means dy value becomes 0. So in the same way, if you are calculating along this line or along this curve, so x equal to a means dx equal to 0. If you are calculating along this curve, this is c1, c2 and c3. So y equal to b means dy equal to 0. So if you are calculating in this way, that is c4. So x equal to 0 means dx equal to 0. Like this, we have to calculate along c1 f dot dr value plus along C2 f dot dr value and along C3 f dot dr value plus along C4 f dot dr value. This value is becomes the final C over this over a complete rectangle. So this is equal to f dot dr f dot dr. So already we know dr is nothing but dxi plus dyj plus dzk. So already they given f value, that is x square plus y square into I minus 2xy into j. Then we can calculate f dot dr equal to x square plus y square into dx plus next minus 2xy into dy. So you can calculate this value according to the limits. We can observe the 10th problem. So that is the given f value is 2x plus y square into I plus 3y minus 4x into j. So what they're asking here, how to calculate line integral, same for the triangle. So they given the triangle, we can observe here triangle is, so they taken 0 comma 0 and 2 comma 0 and 2 comma 1. Here we can take this one in the xy plane. So this is 0 comma 0, this is the x axis and this is the y axis. 2 comma 0, this is the on xy plane. Here 2 comma 1, this is xy and this is in the xy plane. So clockwise, counterclockwise direction we have to do and opposite direction. So if you are taking C1 like this, C2 and C3. So now along the curve we have to take the value. So if x equal to 2 here, what is the dx value? 0. If you are taking here, x value is 2 and y value is, so based on that we have to calculate. Here also like this, we have to take along the curves. After then we can add to get the f dot here along the total triangle. So next part we are having part B. This is the long answer questions. So in the same way we are having line integral problems, surface integral problems, volume integral problems and 3 theorems: Green's theorem, Stokes theorem and Gauss divergence theorem. Gauss divergence theorem. So you can observe here, evaluate double integral over S f dot ds. The given y is, sorry, f bar is yz into I plus 2y square into j plus xz square into k. The given S is the surface along the cylinder they given. So in the cylinder the circle is x square plus y square equal to 9 and z equal to 0 to z equal to 2. That means we can get the 3 limits. That means z limits and xy limits from this circle equation, and from this we can calculate the double integral over s f bar dot ds. So here we are going to calculate the surface integral. Let's see the second one. Find the work done in the moving particle. So the given f, so work done formula integral a to b f bar dot dr bar. So based on this we can calculate the work done value for the given function f. So now see the third one, find the circulation of f. So here circulation of f means integral over c f dot dr is line integral. So for this function we are going to use the limits. So x square plus y square equal to 4, that is in the xy plane. In the xy plane z equal to 0. So based on this we are going to take the x and y limits to integrate the given function along for the circulation. So here see the fourth one, verify Gauss divergence theorem. Here also we have to verify the Gauss divergence theorem. That means we should know about the statement double integral f dot n ds is equal to triple integral over dv of dv, otherwise del dot f dv. So that means you have to calculate the both values and you have to show LHS equal to RHS by using the limits here xyz equal to 0 to xyz equal to a. That means x equal to 0 to x equal to a and y equal to 0 to y equal to a and z equal to 0 to z equal to a. This is our cube. So already we discussed the same problem like this in the previous questions. You can see here, verify Gauss divergence theorem. Here also we have to verify the given function is 2x square yi minus y square j plus 4x z square k. Here take over the region in the first octane. First octane means x, y, z values are starting from 0. First octane means all values are starting from 0. They given y square plus z square equal to 9 and x equal to 2. So based on this we can take x values are 0 to 2. After then we can take the y and z values from the given equation. So see the sixth one, verify the Green's theorem. So Green's theorem is integral m dx plus n dy is equal to double integral over dou n by dou x minus dou m by dou y into dx dy. So for this equation, what is the m value, what is the n value? After that we are going to calculate dou n by dou x and dou m by dou y, and already they given the square. Here they are giving the square. That square is with the vertices we are having. You can observe this is 0 comma 0 and here 2 comma 0, here 2 comma 2 and here 0 comma 2. So we have to calculate these two values, I mean along the C1, C2, C3 and C4, and we can calculate that value by using this limits. And see the seventh one, apply the Green's theorem. That means only LHS part or RHS part we can do or applying the Green's theorem. So here verify means we have to calculate both value LHS and RHS part. We can observe here triangle we are getting. So here for the limits we need to, so y equal to 0. So we are taking the triangle here. So that is this is the x-axis and this is the y-axis. Y equal to 0 on x-axis, y value is 0 and here x value is pi by 2. So here triangle we are getting x value is, and here y equal to 2x by pi and we are getting x equal to pi by 2. X equal to pi by 2 means here we are going to get x value. So this is the x value, x equal to pi by 2 and here this is 2x by pi. This is the, so here by using this we are going to get the limits of x and y. After then we can integrate this function by using this limits by using the Green's theorem. The same way we can calculate the eighth problem also, apply Green's theorem and use the limits here. They given the enclosed, this value is enclosed by x-axis and the upper half of the circle. So from this circle x square plus y square equal to a square, you can get the x limits and y limits. Based on this you can calculate the given function value, integral c 2x square minus y square into dx plus x square plus y square into dy by applying the Green's theorem. You can see the verify Stokes theorem, and here the statement of Stokes theorem is integral f dot dr bar equal to double integral over f bar dot n ds. So based on this curly f dot n ds also we can take here. So verify Stokes theorem we are going to take, this one is verify Stokes theorem here also, and that means we can use the same method and same procedure we can follow to solve the 9th one and 10th one. See the 11th one, here we need to evaluate the surface integral by using the limits. They give an x equal to 0 and x equal to a and y equal to 0 and a, z equal to 0 and a. So then we can calculate over the surfaces of the cube. So 6 faces will be got. So S1, S2, S3, S4 and S5 and S6. So we are adding together to get the total surface value of the cube. So see the 12th one here, we need to calculate the line integral for the function f equal to 5xy minus 6x square into I plus 2y minus 4x into j. So here we are going to get the f dot dr value is by using the dot product. We are getting here 5xy minus 6x square into dx plus 2y minus 4x into dy. So now already we are having the limits. Based on that we can calculate the integral over c f dot dr value. And see here also we are going to calculate the line integral by using the limits. We can observe here we are getting x plus or minus 1 and y plus or minus 1. So based on that we can calculate the function value, that is for the line integral. And see the next 14th one, here we have to evaluate the given function by using the Stokes theorem. So here we can calculate the integral over c e power x dx 2y dy minus dz value by using the Stokes theorem formula. Then we can get the value of this surface integral. And see this is also verify Stokes theorem. That means we have to calculate the line integral f dot dr value and double integral over f bar dot n ds. We have to show these two values are equal. Then we can verify the Stokes theorem. See here, evaluate by Stokes theorem for this function, and we are having the triangle that is 0, 0, 0, 1, 0, 0, 1, 1. So here Stokes theorem statement, here evaluate means we can calculate f dot dr, or we can calculate the double integral f dot n ds also. So any one value can calculate to get the solution here. See this one, verify Green's theorem. Here also for the Green's theorem we have to calculate integral f dot dr value and integral over dou n by dou x minus dou m by dou y into dx dy. These two values should be equal. Then only we can verify the Green's theorem. In the same way we can observe the 19th one. So here we have to calculate the surface integral value by using the cylinder, that is x square plus y square equal to 16 and z equal to 0 and z equal to 5. By using these limits we can integrate the given function for the surface integral. And see the last one, here we have to evaluate the given function by using the Green's theorem. So here we can observe y equal to 0 and x equal to pi by 2. So same we can observe the figure here. So here this is on y-axis x equal to 0, on x-axis y equal to 0. So x equal to pi by 2 means some constant, so x equal to pi by 2, and here we are going to get y equal to 2x by pi. So from this we are going to get the limits of x and y. So if you having the limits of x and y, we can integrate the function by using the Green's theorem, that is integral m dx plus n dy is equal to double integral over dou n by dou x minus dou n by dou y into dx dy. So we can substitute here the values of dou n by dou x and dou n by dou y. Then we can integrate by using the limits of x and y to get the solution of the 20th problem. So this is the way we can solve the given problems in the module 5 by using the theorems, 3 theorems, and line integral formula, surface integral formula, and volume integral formula. So for the more examples, please refer these textbooks. Higher Engineering Mathematics, written by B.S. Gravel, and a textbook of Engineering Mathematics written by N.P. Bal and Manish Goyal, and one more textbook, Higher Engineering Mathematics, written by B.V. Ramana, and we can use this Engineering Mathematics written by T.K. Iyengar also. So please take some more examples and practice more. Then you can get the better clarity about these vector integration problems. Thanks for patience listening. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.